Hello dear friends, welcome to BYJU'S Exam Prep. One second. The comprehensive learning preparation app for your competitive examinations. I welcome all for this particular session of Nielit series. So from today, hello Sanjay Kumar. From today we are going to start with algorithms under this Nielit series. There will be around 4 sessions where we'll try to discuss some important problems as well as concepts with the problems in this particular series. Okay, so today is my first class, so let us start with this particular session. You can share this particular session with your friends so that they can benefit, right? Hi Madhavi, hi, how are you? So this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience and I am associated with BYJU'S from past 2 years. My dear friends, you can join my Telegram group CS_Sridhar to get regular updates about my classes on YouTube as well as app. Okay, so we are coming up with many such initiations. Okay, so please join the Telegram group to get regular updates. You can also join my Facebook as well as Instagram pages, right? So without wasting much of your time, let us dive into today's topic, that is part 1 of the algorithms. It is mainly concerned with the following two concepts. One is asymptotic notation and the time complexity. See, generally from asymptotic notation, the problems which they ask are order of growth notation, and second thing is arrangement of functions according to their order of growth. That is one very important question. Madhavi, the course is already started. I think earlier there were some issues before starting, because as a big organization, any new launch will take some time. But once it is launched, you will not find any difficulties. You can join the BYJU'S Exam Prep app. There, if you connect to this counselor, talk to counselor, they'll help you in joining this particular course. Okay, you'll get full details about the course in BYJU'S Exam Prep app. Okay, or otherwise you can ping me separately. I'll connect with the particular people, my friends. Okay, concerned team members, sales team members, or uh, marketing members, I'll connect with you. Right, right. See here, generally we require this asymptotic notation for understanding the time complexity of algorithms. Time complexity is the amount of computing time, processing time required by an algorithm to run to completion. Okay, see, finding exact time complexity is difficult because it depends on many machine dependent issues. So we try to estimate time complexity, but we are not interested in estimating this particular time complexity for small inputs, my dear friends. For example, most popular uh, problem which you discuss is sorting algorithms. Suppose if I give 10-20 numbers, you don't need any algorithm for sorting those numbers, right? Of course, to understand the algorithm we take 10-20 numbers only. Okay, but the main purpose of the algorithms is not to sort those 10-20 numbers, sir. We want to sort large or big collection of numbers. Am I clear? So when you implement a particular algorithm, we need to know how long it will take for run to completion. But finding exact runtime is difficult because it depends on many machine dependent issues. So we estimate runtime as function of input size. But again, when you are estimating this, we try to see that estimation is as machine independent as possible. Okay, so here we are going to ignore all the machine dependent issues. That's where we use this order of growth notation. That's where we use this order of growth. Hi sir, Vision, how are you sir? That is where we are going to use this order of growth notation, my dear friends. Okay. So this particular order of growth notation, that is called asymptotic notation, okay, tells you or is kind of representation or the notation used to represent time complexity for large values of n. Simply, asymptotic notation is used to represent time complexity for large values of n. That's it. So here we are having mainly 5 asymptotic notations: big O, big omega, big theta, small o, and small omega. But we are mainly concerned with big O most of the time. Even in examinations like ISRO, BARC, even Nielit, they may be using most of the time big O notation, but it is better to know the idea of big theta notation also. Small o and small omega very rare for such examinations. Sometimes in GATE you can find such, these notations, problems based on these notations also. Thank you, sir. Fine, I am fine. See, when you say Fn is big O of Gn, the idea is Fn is asymptotically smaller than G. Asymptotically smaller or equal. See, even though here we written less than or equal to, you see that is a scripted less than or equal to. So we need to understand this scripted notation as asymptotically. That is for large values of n. For large values of n, Fn will be less than or equal to some constant times Gn. That is the meaning of it. Similarly, when you say F is big omega of Gn, means F is larger than Gn. That is, Fn is having big omega as its lower one. Fn is larger than what? Some constant times G. So this is the idea, my dear friends, for big O and big omega. See, here we can find at least one C and one N naught such that this condition satisfies for large values of n. This condition happens for large values of n. Okay. What we need to understand is, for this particular function, what is the tight bond? See, actually speaking, if you want to say, suppose your function is say n power 1.9, you can say it is bounded above by n square. Of course, you can also say it is bounded above by n power 3, it is bounded above by n power 4, all that you can write it, but mainly in the examination they expect you to write the tight upper bound like big O of n square, they expect, my dear friends. Am I clear? But strictly speaking, all are correct only. All these are asymptotic upper bounds only. For n power 1.9, all these are asymptotic upper bounds. Am I clear? Or you can take like, n square plus 2n plus 5 is there. For this, you can drop the lower order terms and you can write it as big O of n square. Actually, for polynomials, you can directly write big theta of n square also, my dear friends, without loss of generality. Without any problem, you can directly write it. Okay. See, the asymptotic notation is the estimation or the notation used to represent time complexity for long run behavior or large values of n. For large values of n, time complexity approaches some function. So to represent that particular function, we use asymptotic notation. That is the simple idea, my dear friends. Okay, like that. So Fn is big O of Gn means F is smaller than G. F is big omega of G means F is larger than G asymptotically. And Fn is theta of Gn is F and G are having same order of growth. That is, you can find constant C1 and C2 such that this condition is satisfied. For large n, my dear friends. See, for large n means after this n naught, this condition will be always satisfied. Of course, this Fn is small o of Gn means it is asymptotically smaller, not equal. It is asymptotically smaller than G, my dear friends. It is asymptotically smaller than G. And when you say Fn is small omega of G means F is larger than G but not equal to G. That is the idea here. Hi sir, hi Sham. So let us take the following example, my dear friends. After understanding the basic comparison of functions, let us start with problems. See, of course, this entire session and the later sessions also, I'll be taking problems and the concepts are explained through problems. Yeah, take this problem. What is the answer for this? Sham says B is the answer. Very good, Sham. So if you actually expand this particular function, it would be n plus 1 into, see, log n square plus 1 can be written up approximately as log n square, no problem for that. And this can be written as 3n square. And this can be written as n into log n square plus log n square plus 3n square. And here you can consider log n square. Very good, Anuja, Chandan Kumar, very good, super. So log n square is nothing but what, sir? Log n square is nothing but 2 log n. So this is nothing but 2 into n log n, or you can say n log n, and it is 2 log n. Ignoring the coefficients, log n it is. Here also you can ignore the coefficient n square, or you want you can keep the coefficient, later on you can ignore that. And here you can obviously understand that the lower order terms in comparison with n square, n log n and log n are small, so you can drop them. You can drop lower order terms and ignore the coefficient of highest order term. So what happens? This is actually big theta of n square. See, whenever it is big theta of n square, you can obviously write big O of n square and big omega of n square. Both are fine, sir. Whenever, hi sir, good evening. Whenever it is big theta, you can write big O as well as big omega. But when it is big O, you cannot say big theta or big omega. Remember that. So big O is given. So B is the correct answer. Wonderful. Now, when you want to compare the function, this is one of the very important result one should know. This is one of the very important result one should know. Okay. See, here it is polylogarithm, it is polynomial, it is exponential, it is factorial, it is n power n, and it is 2 power 2n. Am I clear? 2 power 2 power n. Now, if you observe, any polynomial is smaller than, that is log power a n is asymptotically smaller than n power b, which is asymptotically smaller than c power n, which is asymptotically smaller than n factorial, which is asymptotically smaller than n power n, which is asymptotically smaller than 2 power 2n. 2 power 2 power n, not 2n, 2 power 2 power n. See, my dear friend, this is your basic ordering, my dear friends. Never forget this. See, what is moral of the story here is, for example, if I have log power 100n and if I have n power 0.0001, can you tell me which one is larger? First function or second function? Left side fellow or right side fellow? Which one is larger? So asymptotically, maybe for smaller values of n, the left side function may dominate, may be larger. But for large values of n, see, my dear friends, here we are interested in comparison of the functions asymptotically. See, asymptotic means long run behavior, limiting behavior. For large n, what is the scenario? That is what you want to understand. So you can simply observe here A positive, B positive, C greater than 1. This you should remember. Then this result always satisfied. So whether it is log power 100, या 1000, या 10,000, asymptotically this fellow must be smaller than n power any epsilon, any small power, my dear friends. Please note this point. And if you can understand these basic ideas, majority of the question can be answered just like that. Majority of the questions can be answered just like that. Similarly, n power b, as long as b is constant, is smaller than c power n. For example, if I have n power 100 and if I have 1.00000001 whole power n, even here this n power 100 is smaller than this 1 power, or 1, not 1 power actually, 1 point something power n. This you should always remember. This is one of the important idea or basic, what do you call it, as order of growth. One should remember. Polylog is smaller than, or asymptotically smaller than polynomial is asymptotically smaller than exponential. This is very important. So please note this, remember this. And also you can remember some very basic functions, my dear friends. Okay, they call it as dominance ranking. Basic dominance ranking they call it. What is this basic dominance ranking? One is smaller than log n, is smaller than root n, is smaller than n. One basic ordering or basic dominance ranking you can call it. After that you can have any powers like n square, n cube, followed by some constant power n exponential, which is followed by n factorial. So this is our basic order of growth, my dear friends. One should always know this. Nice. What is the answer for this question? Now we are going to take up some very interesting problems. Let us solve. Increasing order means small to large. Shyam Babu, increasing order means small function to large function, not large function to small function. C. Anuja Gosavi, very good, as well as CS Vision. Beautiful, wonderful. See, this is very straightforward thing, my dear friends, from the result. Okay, from this particular result, it is very straightforward. Okay, that is, c power n is smaller than n factorial, is smaller than n power n. The very basic ordering, my dear friends. Of course, there is one more way of looking at it. What they do is, you have this 2 power n, n factorial, n power n, apply log to these functions. So you get log 2 power n, log n factorial, then log n power n. So this is nothing but n log 2, and log n factorial is theta n log n. Okay, log n factorial is theta n log n, and log n power n is n log n. Now people feel that these two are equal. You can't say this. This is very bad thing, my dear friends. Okay, here you can easily understand this is smaller than this. So for this method log application doesn't work. But here you can easily understand n into n factorial means n into n minus 1 into n minus 2 and so on up to 1. Obviously, n is less than or equal to n, n minus 1 is less than n minus 2 is less than n, and so on. 1 is also less than n. So obviously, you can prove that it is less than or equal to n power n. So by this method, you can easily verify that n factorial is smaller than n power n. So obviously, the correct answer for this is C, my dear friends. Sham, okay, I think you understood the result. अगला समस्या, नेक्स्ट प्रॉब्लम आपके स्क्रीन पर. Sterling formula you can use for, deriving log n factorial is equal to theta n log n. You can use Sterling formula also. Yeah, there. B. See, my dear friend, whenever you find this n power 1.3, n log n, log power 4n, n power 7 by 4. See, actually you can write it as n into n power 0.3, n into log power 4n, n into n power 3 by 4. So here the common factor you cancel out. So when you cancel out the common factor, it is n power 0.3, it is log power 4n, it is n power 0.75. And we all know that this fellow log power an is smaller than n power any fraction. Correct or not? So obviously this is the smallest fellow. So this will go here, then this will come here, and this will go here. Like n power 0.75 is larger. So corresponding function n log power 4n, this is n power 1.3, this is n power 7 by 4. So this is the correct order. So n log power 4n is less than n power 1.3 is less than n power 7 by 4. Nice, no? See, these are all very basic questions, but I always find people do a lot of mistakes in this. The problem might be not knowing the basic rules. See, after knowing the rules, you need to know how to apply them. See here, if you can write the rule, it is of no use, sir. The rules are available in every book, every notes, everywhere it is given, sir. If you just keep those rules in your pocket, it is of no use. Okay, don't do fixed deposit, babu. You have to use them. Okay, you have to use the rules. Am I clear? It is a risky thing because you may misuse the rules, you may do mistakes. Okay, you may manipulate the rules also. So please be careful, but you have to use the rules. Am I clear? You can't keep them in the pocket. Am I clear? We have to use them in the market. Remember that. अगला समस्या आपके स्क्रीन पर. Sham Babu says D. Sanjay Kumar also says D. And as usual, CS Vision by ER Chandan Kumar says DD. Anuja Gosavi says, sorry if I mispronounce any of your names. Okay. Artipal says C. Wow. Okay. So let me reveal the secret. The correct answer is B. The correct answer is option B, Babu. Why? Let us see. See, my dear friends, in this, the odd man out is 1 by n because so far we never seen this fellow. 1 by n we never seen. It is a new fellow for us. But if you observe the other fellows, 1 is smaller than log n, is smaller than root n. This order, you know it. This order, you know it. Now the problem is with 1 by n. इसके लिए हमारे पास एक इलाज है. Whenever you have two functions, there is a simple limit formula. Limit as n approaching infinity, fn by gn you do it. Suppose this answer is say a. If a value is 0, what does it mean? The denominator function gn is large. In this particular case, you can say fn is asymptotically smaller than g. You can directly announce this. Sometimes this a may tend to infinity. In this particular situation, you can say that because if tending to infinity means numerator function is larger, f is asymptotically larger than g. And the third situation, this a not equal to 0 but finite. In this particular case, these two have equal order of growth. These two functions are having same order of growth. See, this particular limit formula is very useful. You can use this formula whenever it is needed. So here I use this particular formula for fn is equal to 1 by n and gn is equal to 1. When I use this fn by gn, already it is fn by gn is there now, so fn is 1 by n by 1. 1 by n by 1, which is 1 by n, which tends to 0. So when the limit tend to 0, that means that fn is smaller than gn. That is 1 by n is smaller than 1. Therefore, 1 by n smaller than 1 is smaller than log n is smaller than root n. That is the solution. So, the correct option is option B, my dear friends. What is the correct answer for this problem? Option B. See, I always see students mess up with large problems from market. See, without understanding the basics, please don't blindly solve the problems. There may be some questions which are based on misconceptions, which is very dangerous. See, my dear friends, if you don't know or if you don't understand a particular result, you are safe, the result is safe. But if you misunderstand, you, the result and the future generation in danger. So please don't misuse the rules. It is all about application of the rules. Am I clear? What is the answer for this, Babu? Please give me the answer for this problem. What is the answer for this problem, Babu? Okay, Anuja says B, Sanjay also says B. That is only second one is correct. Fn is larger than Gn. How come? Hi? How? How? Babu, if you observe n power c, n power log n, what we do is we apply log on both sides. Let us apply log. By applying log, what happens? It becomes c log n and it becomes log n into log n. यानी ये होगा log n और ये होगा log square n. Constant you can ignore. Obviously log n is smaller than log square n. See, if log of fn is asymptotically smaller than log of gn, so obviously fn also will be asymptotically smaller than gn. Only when log fn is smaller than log gn, this happens. Remember. So by this what happens? Clearly n power c is smaller than n power log n. N power c means fn is smaller than gn. That means you can say fn is big O of gn, bounded above. So only A is correct, B is wrong. अगला क्वेश्चन, समस्या आपके स्क्रीन पर. कोई बात नहीं सर, I also did so many mistakes, so I started teaching. Nice, it happens for everyone. Dare to do mistakes, care to correct it. Don't repeat the same mistake again and again. It is a simple rule. Follow. अब क्या होगा? Sanjay now says B. That is only 2 you say. Let us check again. N power log n, 2 power n. Apply log on both sides. So you get log n into log n, which is log square n, and it is n into log 2. Obviously log square n is smaller than n. What does it mean? What does it mean? Log n into log n, log square n is smaller than n, correct? So obviously what happens? N power log n is smaller than 2 power. Very good. One more simple problem to stop or close this order of growth. Then we start with time complexity problems. Anuja Gosavi doing very well. Sanjay Kumar, no problem. See, my dear friends, there are certain issues. One thing is, in previous example also, I said apply log, you not use that. See, mostly people depend on their memory. Of course, memory is required to remember the standard rules. But remembering solution of the problem also memory is not required. Hello, Chenchal Sharma. Hello, no. How are you? Okay. So no one answering. See here, one thing which we need to understand is, if you observe 1.0001 power n and e power n, so obviously 1.0001 power n is smaller than e power n, because e is 2 point something. Okay. So power is same, base whatever is larger base, that will be dominating. So this order is fine. Now here for this fellow we need to fix the order, because obviously the polynomial fellow will be smaller than these two fellows. So obviously this is the order, that is D and E is fixed. D is in 3 options, so this is ruled out. Check, let us check Madhavi. Okay, Chandan Kumar, let us check. Wait 1 second. Hopefully your answer is correct. Let us complete it. Now here you see n power 1 by 3.33 something. It is n power 7 by 4 and it is n into log power 8. So if you observe this n power 1 by 3, it is n into n power 3 by 4. It is n into log power 8n. See, obviously here we have n factorial n power 1 and it is n power 1 by 3. So obviously n power 1 by 3 is the smallest. Now out of these two fellows, if you remove the factor n, this log power 8 is smaller than n power 3 by 4. So obviously the correct order would be n power 1 by 3, n into log power 8n is smaller than n power 7 by 4. That fellow will be smaller than 1.0001 whole power n is less than e power n. That is a less than c less than b less than d less than e, that is c. C is the correct option. So here my suggestion for all of you, if you want to understand order of growth notation, first thing we should understand is, what do you mean by this? Whether a right belongs to or equal to, the meaning is f is smaller than or equal to g for large value. Actually come constant times of g. Some constant times of g. But you are writing asymptotically, that is what we need to understand. Okay. So mainly this is used, sir. And if it is big omega, you need to understand f is larger than or equal to g. And theta means they are of same order of growth. And remember this log power a n smaller than n power b smaller than c power n smaller than n factorial smaller than n power n basically. And thing to be remembered here is a, b are positive, but c should be greater than 1. Even that is very important. Even that is very, very important. There are this type of question they asked in Nielit examination. So I just changed that numbers and asking here. There are 2 algorithms for processing a file having 2 power x records. Nice. So we are having this many records, sir. 2 power x records. Algorithm A takes time 8n log n. Okay. This is n value, sir. N is 2 power x, he says. See, algorithm A takes time of 8n log n for the input n, which is 2 power x, whereas algorithm B takes a time of n square respectively for processing these records. Madhavi says C. Ocha, previous question, huh? Right, Madhavi? Previous question, Chandan and Madhavi both are correct. The smallest value of x for which algorithm A is asymptotically smaller than B. What is the smallest value of x for which this A is asymptotically smaller than B? So you want A. A means what, sir? 8n log n. to be smaller than b, that is n square. So you have to tell what is for what value of x this condition will be satisfied. Put n is equal to 2 power x, my dear friends. So 8 into 2 power x log 2 power x less than 2 power x whole square. And you can cancel 1 2 power x with 1 2 power x, so that it is log 2 power x. 8 into log 2 power x is nothing but 8 into x into log 2. Log 2 is 1, which is less than 2 power x. That means x less than 2 power x by 8. So for what value of x this condition must be? What is the smallest value of x for which this condition is satisfied? See, again verifying, solving this, don't always do that, my dear friend. Here x values are there, substitute and verify. You can directly substitute the value of x5, verify with 5, x is equal to 6. 4 values you substitute and verify. After this, what you do is do verification. After this, please do the verification. So putting x is equal to 5 will give you the answer. 5 less than or equal to 2 power 5 means 32 by 8. 32 by 8. 2 power 5 is 32 only nowadays, yes, by 8. So 8 4 32. So 5 less than 4 is false, which is wrong. So x is equal to 5 is not correct. Try x is equal to 6. 6 less than 2 power 6, 64 by 8. So 6 is less than 8, which is right. So the minimum value of x, very good, B is the correct answer. Super, wonderful, nice, great. So now we start with the time complexity problem. The basic idea of time complexity is the definition, you can call it the amount of computing time or processing time required by an algorithm to run to completion. This is what you mean by time complexity, my dear friends. This is time complexity. And we estimate time complexity as a function of input size. Okay. And for that, we need to introduce a notation or notion. Okay. And we use the notation of the step size. Okay. And the time complexity is estimated like this: cost of statement into number of statements over all statements. This would be your estimation for time complexity. Of course, it is the first estimation. Later on, we use order of growth notation, where we ignore the lower order terms, then or drop the lower order terms because their effect would be negligible, and ignore the coefficient of highest order term because that coefficients are all machine dependent fellows. So we can ignore all of them, my dear friends. So this is how we are going to estimate time complexity, my dear friends. Okay. And here, when you consider the sequential or simple statement, any single statement or multi statement, as long as finite number of statements, they'll take constant time. And if it is if else block, if you are having maximum of if else block, you are going to consider as the time complexity. Mainly when you are having loops, this time complexity will be affected, because The loop, what happens? Suppose the loop variable depends on the size of input. Then what happens? The same statement need to be executed number of times. Therefore, ultimately time complexity will become function of n. See, as long as there are no loops, all are simple statements, sequential statements, simple blocks with finite number of statements, that is all constant time, my dear friends. But when you are having the loops, then what happens? If the loop variable depends on the input size, so ultimately what happens? You can write time complexity as a function of input size. And that particular function of input size we try to estimate again using order of growth notation by dropping lower order terms and ignoring the coefficient of highest order term. So that is the story, my dear friends. So for that we have some standard loops and their time complexities. See, if you consider for I is equal to 1 to n in steps of any constant, whether it is single constant plus 2 plus 3 plus 1, as long as it is constant, or from n to 1 in steps of a constant difference. Okay, 1 to n with constant addition, n to 1 with constant subtraction. Whenever you are doing it, the complexity of this both the loops is given by theta n. What is the complexity of this? Tn is given by theta n, my dear friends. These are the standard loops you should remember. The next one. The next one, if you are reaching 1 to n in multiples of c, you have n to 1 in multiples of 1 by c. In both the cases, the complexity would be theta log n. The complexity would be theta log n. I think most of you know the standard loops, my dear friend. These standard loops we should master at least. Of course, you can do derivation. Generally, in our regular classes, we do derivations and other things. But here, at least know the standard, because the standard loops, okay, the variation you can easily understand, my dear friends. Base will be c, but the base of logarithm asymptotically does not matter. So you can write theta log n without any problem. Then 2, here it's not 1 to, sir, it is 2 to n, where every time you are raising to the power of c, some constant power you are raising. It may be power 2, power 3, power 4 and so on. In this particular case, or starting from n, you are going down to c, every time you are raising it to the power 1 by c. C can be 2, 3, 4, any constant. In both the cases, the time complexity is given by theta log n. Theta log n. Hi, Nakwi. Okay. Is that clear, sir? Hope you all understood. The logic is clear. The logic is clear. Okay. Of course, logic, if you want to understand, you have to see how it goes. See, suppose if it is power c, first time it is 2 power c when you raise it to power c. Next time it is 2 power c whole power c, which is nothing but 2 power c square, and it continues like 2 power c power k minus 1. And this value equal to n means c power k minus 1 is equal to log n, yani k minus 1 is equal to log n. Here it is base c. As I told you, base of logarithm does not matter. So the time complexity for this is theta log n. That is the story. Babu, answer the questions. Now we have simple problems. Let us quickly close the session with good number of problems. The next session is on, today is third, na? Fifth. That is like divide and conquer and greedy. Divide and conquer and greedy algorithms we are going to discuss day after tomorrow. Only problems. No theory, only problems. Madhavi says A. Very nice, Madhavi. So you are multiples of 2, you are reaching n square. See, if you reach n, it is log n. Because you are reaching n square, the time complexity would be theta log n square. Which is nothing but 2 log n. So the answer is theta log n. Oh, the answer is option A, not B. Sanjay Kumar. Acha, Madhavi, you given correct answer. Sorry, Sanjay given wrong answer. Sorry, Madhavi, you are done. Nice. You are doing really well. Madhavi, you are regular student. You are... Hi, Madhavi. You are answering questions really nice. You are regular student or just attending random classes here? अगला समस्या आपके स्क्रीन पर. Please answer the question. Very good. Please do join my Telegram group to get regular updates. Okay, and you can connect with me regularly. Okay, for any other doubts or any other help. Okay, please try to answer this question. What is the answer? What happened, sir? Okay, see here x value is 10, so n is 10. So you are reaching 2 power 10. 2 power 10 means what, sir? 1024. See, you are reaching 1024 in multiples of 2 means, log. Okay, see what is the answer? Log 2 power n. So log 1024, that is nothing but 10. That is nothing but, hi Anuja, good idea, but there is some mistake you done, because there was a trap in this particular problem. There was a trap. X value 10, n is equal to 10. So you are reaching only 1024 means only 10, roughly 10 or 11 iterations, which is constant. So the answer is theta 1 here. So there was a trap in this particular problem, Babu. Please note that. So D is the correct answer. Very good, CS. CS Vision, you are also answering quite well. Good. Good attempt. Anuja, earlier you are giving good answers. Nice. Okay, that was a trap. Expected. Good. Next one. See, we can have nested loops also. That is loops inside the loop. And here there are two types of loops. One is called dependent nested loops. The other one is called independent. Independent in the sense here J is not depending on I. So we call it as independent. In that particular case, you can just see how many times it iterates. and how many times it iterates. Okay, you please just verify, how many times this loop iterates and how many times this loop iterates. Multiply, you will get the answer. See, the outer loop iterates n times because you are going from 1 to n with uh, constant value addition every time. So this loop iterates n times, whereas second loop iterates because you are reaching 1 to n square in multiples of constant, so it is log n square. So this iterates log n square times. It iterates log n square times. So what happens, log n square is nothing but log n square is nothing but 2 log n, yani log n. So the time complexity here would be simply theta, multiply those two fellows, n into log n. That is option C. This was recent GATE question, so asked in a different way, same question. So GATE question answer, you know, that is wrong answer. Chandan. Actually, this is a Pascal code. Here you see n value when it is n. See, generally we use I is equal to n like that. Now he used n is equal to n. That is the confusion for this particular problem. Okay, n is there. See, for n we iterate, I will iterate n time. I varies from 1 to n. Therefore, this iterates n time. When n becomes n by 2, next time I iterates from 1 to n by 2 only. That is, this time it iterates n by 2 times. So when n is n by 2 by 2, that is n by 2 square, I varies from 1 to n by 2 square. That is n by 2 square times it iterates. See how long it continues, sir, till this n by 2 power k becomes 1. So in this case what happens? It iterates from 1 to n by 2 power k, maybe one iteration. So it is roughly n by, because for n is equal to 1 you come out of the loop. So maybe n by 2 power k minus 1, till that time only this iterates. When n is equal to 2 power k you come out of the loop. So you can say n by 2 power k is 1. So we are iterating n by 2 power k minus 10. So this is what is the work done, my dear friends. So the time complexity would be sum of all this. That is n plus n by 2 plus n by 2 square plus and so on n by 2 power k minus 1. Taking n common, which is 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 power k minus 1. That is what happens to this. Okay, a into 1 minus r power k by 1 minus r when r value is less than 1. So we can write 1 minus 1 by 2 power k by 1 minus 1 by 2. This denominator becomes 1 by 2, 2 will go up, so it is 2n and it is 1 minus 1 by 2 power k. See, here we assumed that n by 2 power k is equal to 1, therefore 1 by 2 power k is 1 by n. Substituting that, so here I am covering the solution. So what I do is, from here I'll complete this. It is 2n into 1 minus 1 by n, which is nothing but 2n minus 2, which is nothing but theta n. So the correct answer for this problem, or theta or big O of n. So that is the correct solution for this problem, my dear friends. Okay, so what I do now is, I'll give you some homework questions. Please write the solutions in comment box. I expect you to complete these solutions and write the solutions in comment box. First problem, second problem, third problem, fourth problem. of course, this insertion sort algorithm question. We'll try to discuss insertion sort. For those who want to understand the insertion sort, the logic is very simple, sir. You take, see, suppose if you are having cards in your hand, suppose you get a new card, you try to keep that card at its correct position. That is exactly how insertion sort works. So if it is 10, 4, 7, 23, 67, 12 and 5, see, in the first iteration, see, single number is always sorted. In the second iteration, I mean in the first iteration, we start with this, my dear friends. We start with here. So what we do is, okay, you consider this particular number. Now you try to keep that at its correct position. Because 4 is smaller than 10, 4 should be placed to the left. See, here we are going to consider only up to here, sir. Only up to here you are going to consider in insertion sort. 4 is taken, it is compared with 10. 4 is smaller than 10. So 4 is moved left, there is no more element. So we keep it here and 10 is moved to the right. So what happens? 10 moves right and 4 is placed here. So these two numbers are sorted. Remaining numbers 7, 23, 67, 12 and 5. This is after first pass. After first pass, this is what happens. Now in the second pass, what happens? We are going to consider only up to here. Now you take this 7 and keep it at its correct position. 7 should go here. So now it is 4, 7, 10. Remaining we not yet started working with them, 12 and 5. So now we have to consider up to 4. So this is after second pass, this is the answer. After second pass. Okay, sir. Now 23 should be placed at its correct position. That is obviously correct position of 23. So this is the answer after third pass. No change. So the answer would be 4, 7, 10, 23, 67, 12 and 5. Which is option B. Very good, Vision. Dear Vision, you are answering well. Okay, keep rocking. Keep attending the sessions. Okay, you can join my Telegram group. For those who do not know my Telegram group ID, it is simply cs_Sridhar. To get regular updates about my classes, you can join my Telegram group. Okay, and we'll meet again day after tomorrow. Not only that, we are coming up with some interesting initiatives both on YouTube as well as app. See if, oh, very good, Chandan, super, good, nice. It is very useful if you are an old student, you already studied the concepts. Okay, see, definitely Nielit examination, there may be some logical questions. We can't say that it is not, it is very, very simple, but it is not very good, very good. Okay, so gate preparation, if you done it, Nielit would be very simple. Okay, simple in the sense, it's not like just you can do it, sir. Questions will be of logical nature, but you can easily handle them. They are not like complete gate level questions. Okay, so all the best and join me on 5th. Again, we'll meet on 5th at same time, 10:15 p.m. This time we'll discuss the topics divide and conquer and greedy. If you want any particular session, particular topic to be discussed, okay, either in app, okay, or in YouTube sessions, okay. Namaskaram, sir. Please let me know. You can connect with me, okay. You can join my Telegram group and get regular updates, and you can ping me separately also, so that, okay, we can discuss about these classes, right? Thank you very much, sir. And thank you, Satyadis Sahu, sir, for attending my session.